Or no, it doesn't, because we're done at 11.
Yeah.
Yeah, that's right. All right. So just a quick explanation, I guess. This here I had set out. This is really for next week, but to quote unquote be on track. Like if you're on track for your 25 topics and you're with this pace of homework 12, homework 13. Homework 13 technically is the first 3 topics would get you to your 25. Or 3 topics from packet 13. So I'm going to post the first 3 videos. So if you need to look through them, you can. I don't think you would for topic 2, and maybe not 3 because they're pretty easy, I think. Topic 1 we've done. Topic 1 we've done. But it is a little bit trickier one, so that you might need to just get a refresher video on that, but I think we've done that. So if you haven't grabbed that, it's for next week. We're not going to start on this today, but we're going to finish out homework 12. Did anybody watch my videos I posted? Probably not. So here's what I did second hour. Really today I want to go through topics 12, 13, 14, 15, 16. We're not going to do every single one. I'll explain the plan. One of each for some of it. Okay? You guys ready back there?
Yeah.
Okay. But what I do want to do is talk about topic 11 a little bit because it's something that my Algebra 2 people have never seen. And if you didn't watch the video, I'm just going to go through one of them. Topics 10 and 11 are really the same thing. Okay? And then topic 9, what was 9? Oh yeah, we're gonna do 12 today. We're in number 12, yep. So, here we go. Okay, so topic 9, I'm gonna do 1, because it's kind of weird. To me, it was supposed to be simpler than it is. So we're gonna talk just this last one in topic 9, and then I'm gonna do the last one in topic 11, because I posted videos for that stuff yesterday. But that way you'll still have one of each in person. There's more videos if you need to see more. And then we'll get into today's stuff. So, the last one of topic 9 is where I'm going to start, just because it's got kind of a weird, I guess I could use this one too, it doesn't really matter. But to me, when they're having you find the product of linear factors, to me I would think like x plus 3, x plus 7, right? Or maybe not, right? So when I saw this, I was like, cool, these are going to factor. But you're going to see they don't. And I just want to show you how to write those. So on this one, they're giving us a 0 of -2. They want us to find the rest of them. How many zeros should this one have? 3. Well, I should say they want us to find the factors. So the factor for this would be x plus 2. We have one of the factors. They gave us that. We're going to use the 0 with synthetic division. Okay, to find the other factors. So I go 1, 4, 2, -4. Bring down the 1. I'm doing my synthetic division with the 0 they gave us. What should my remainder be?
No clue.
I like the honesty.
Would that be
Your remainder, if it's a 0, or if it's a factor, okay, your remainder is 0. Okay, so let's keep going. That's just a kind of a check, make sure we got it right. So I kind of like these because it's kind of hard to mess it up if you know that. Because if you don't get 0 for a remainder, then you're going to go, oh, I messed up somewhere. Alright, so now I'm going to put this in, my x is back in. They want us to find the other 2 factors. So when I was doing this, I was like, cool, alright, we're going to factor. But this doesn't factor. So I was like, are you serious? So I actually had to wait to get to it in Alex because I was like, I'll get to it and then look at the explanation. So here's what we have to do. Our friend, the quadratic formula, comes back into play. This thing, we just can't get rid of it. It just keeps coming back and back and back. Okay, so negative b over 2a. Plus or minus squared, b squared minus 4ac. I don't know why I said it though. Okay, we're going to put in our ABC. So negative b would be -2 plus or minus. Okay, so b squared would be 4. -2 2 times A, there we go. This is where I was like annoyed by this topic, cause I was like, anyway, we'll just do it, it'll be fine. So negative 2 plus or minus, so we end up with the square root of 12 over 2. And we're back to solving or simplifying the square root. So I've got this square root business I have to think through. Square root of 4, square root of 3. So simplified, it would be this 2 square roots of 3 over 2. And then I can divide by 2, right? So I went through this one in a video for yesterday if you were like trying to stay on track with your packet. And I did all of them. I'm just gonna do one of each of these here today. If you need to see the next one, it is posted. I was gonna show Google Classroom too, so hang on a second. Okay, so we divide this. This is just 1 here, but we don't need the 1. So we found the other 2 zeros, but here's what's kind of gross about these. They want you to write them in factored form. Okay?
Oh, no.
Oh yeah. So here it goes. It looks like this. And like I said, I looked it up and I was like, oh, that's disgusting. So here's what it looks like. It would be, it's always x minus when you're doing factors. Always. Because it's just the opposite. You're bringing it across.
Minus negative 1.
So it'd be minus negative 1 plus the square root of 3 minus negative 1 minus the square root of 3. And that's your answer. This right here would be our answer. There's our 3 factors. I kind of, when I saw that, I was rolling my eyes a little bit. But I will say this right here leads us to what we have to do in topic 14. So on this topic, when it says write as a product of linear factors, you're gonna get some of these irrational zeros, and then you have to put it in the x minus. And you can just leave it like that. So it's kind of an ugly answer, but it was just unexpected. I was like, oh, okay. All right, so I'm not gonna do that one. If you want to see all of it, the video's posted. I am gonna do one of these 10 because, or actually I'm gonna skip 10. The video's posted. 11 is the same. I'm gonna do the last one of 11. So 10 and 11 are the same topic. Just one's got more factors than the other. And again, it's all posted for your viewing pleasure. Or if you do go, I need to see another one, you can pull it up. So the last one on topic 11, this is another thing I was sort of shaking my head at. And this is something my Algebra 2 students have never seen. And maybe not my pre-calc kids, because with technology, this is sort of an out-of-date theorem. It's called the rational zeros theorem. Basically, you use the theorem to find the list of possible rational zeros. We're going to list all of the possibilities. And then in the olden days, like when I learned this, I had to go through every single zero, do synthetic division, and see which one's got me a remainder of 0. I'm going to do it every single one. And that took a while. Now we have graphing calculators, we punch them in and we can see where is it across the x-axis, and that's my rational zeros. Okay, but there are 2 topics that you have to list the possible ones, which we can't just put in the calculator. So the rational zeros theorem, you're taking P over Q, where P is this last term, Q is this first one. It's the factors of P, the factors of Q. So what we do is we'll find for P, it'd be the factors of 9. Okay, so I would go through 9, and it's going to be plus or minus 1, plus or minus 3, plus or minus 9. Alex did help us out a little bit on this one. It gives you a plus or minus button, so you don't have to type in 1, negative 1, 9, negative 9. It's got a plus or minus button. All right, then we have to find factors of Q. So we're just going to take, or not, this is Q, is number 4. Factors of 4, plus or minus 1, plus or minus 2, plus or minus 4. And then the list of possibilities for zeros is taking P over Q for all of them. Oh yeah, it's not crazy hard, it's just, in my opinion, kind of a outdated theorem. It's helpful if you know you're not gonna have a calculator doing this, but I think, in my opinion, when we're doing this advanced math, you're gonna have your calculator or Desmos, or you're gonna have tools to work with. But anyway, we'll figure out the topic. So P over Q, so you're just gonna basically divide everything by each P divided by each Q. Okay, and I'm not sure why it's backwards alphabetically, but P is the last term, Q is the coefficient on your first term. So we're saying P over Q. So the first one we divide by 1, so it's just the original factor of 9. Now we're going to go through and divide by 2 to each of the factors of 9. So I'd have plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. These are all the possibilities. Lastly, I'm going to divide all of these by 4. So then I would have plus or minus 1/4, plus or minus 3/4, plus or minus 9/4. So they're not all this long. This is the advanced. That's why I'm just showing you like the longest one. The other ones, you'll divide and you'll get some that will repeat, like 2 over 2. Well, you already have a 1. So you're not going to write the repeated ones. It says don't write, it even says that, oh yeah, be sure that no value in your list appears more than once. So that happens with other lists, like they'll double up. You'll go, oh, I already have 2. But this one does not, so this would have all of them.
I love having 18 answers.
I know. I mean, again, it's not crazy hard, it's just sort of out of date. So back in my day, I would have to go synthetic divide with 1. I'm not going to do it all. And then I would do that. And if it wasn't 0, I would go, okay, let's try -1. And if it wasn't that, okay, let's try 3. And then let's try, it was a lot of work. So typically they didn't give us ones that had this many. Okay, so that's finding rational or possible zeros. You're taking P over Q. And then you just get this list of these are all your possibilities to try. Okay, now in 2022, we're going to use our graphing calculator. Okay, but that's that topic. So when you get to that, you know at least you've seen one. If you need to see more, again, I posted the videos yesterday. Before I dive into this, just real quick, I almost forgot. What I did in period, well, all of them, all my classes, is I put at the top, blank and filled out. These are kind of late to the party, I realize. But blank and filled out packets, so maybe when you get to the final time and have to study, are listed at the top here in classwork. So here's homework 11 filled out, 12 filled out, 13 coming. The other thing that I posted at the top here is this test retake or makeup form. And that's just to help me stay on top of all the different testing coming in. So what I'm finding is I'm not, I'll be like, oh, who was it that tested like, now? Or who was it tested first period? Even if you're with me, if you fill this form out, it's real fast, you show up in a spreadsheet for me, and then I can go, oh, here's all the people that I have to look at their scores. It just makes it a lot easier. So anytime you're doing a test retake, makeup form, even if it's during a blended day, if you can just fill this out quick, then I can get your score quicker and updated quicker, because you'll be in my little test taker list. So I'm trying to get organized a little bit. Okay, flipping back. So we're going to finish packet 12, kind of. I'm not going to do every single problem. Tomorrow's blended. I'm going to post videos for homework 13, 1 through 3. That's why I gave you the packet. If you get to that point and you need to watch the videos. Topic 2, I don't think you need a video. Topic 3, maybe a little bit, but so I'm going to post it if you need it. So I just gave you that to get you started. All right, homework 12, I say we're sort of going to finish, because what we're going to do, it's 12, right? Yeah. So here's the order. We're going to do topic 12, one of them, topic 13, one of them, and then topic 16, one of them, because they're all the same. The only difference is in the type of answers. So this we get rational answers. This we're going to get irrational answers. This, we're going to get imaginary answers. So, I'm not gonna do 2 of each of them, I'm gonna do 1 of each, and then we'll come back and do 14, 15. The 16 kinda goes with these. Then we'll do 14, 15, ooh, and then we'll be done. Sound like a plan? I should have written this out to my other groups. They were so lost when I jumped to 16. Anyway, so I'm gonna do 1 of each of these. You'll see how they're all the same, 14, 15. Okay, here we go. So, topic 12. This is where, in the past, this is a real pain in the rear. Because in the past, what we would do is use one of the possible zeros from the rational zeros theorem to find the actual, like we'd have to keep dividing until we find the 0, and then reduce to a quadratic and solve. Well, what we're gonna do is put this in our graphing calculator and find the one rational 0. Okay? Oh, and mine, when I was doing all this rigmarole, the internet, it kicked out. I don't know why. There it is. Which bums me out, because I had them all there already, and then it like glitched out. So yeah, we'll type this in. Now this is saying they're rational. So quite honestly, all of them will be on the calculator when they're rational. But I'm gonna use the synthetic division just to practice that. If you don't know what decimals it is. Oh, there it is. We're gonna graph this one, number 12. Okay. So we'll put this in. I have them over here for myself. Okay. Alright, some of them got dead. Alright. So rather than doing P over Q, P over Q, P over Q, we're gonna do this. Alright. Because it's rational, they don't want decimals, they don't want decimal answers, but these are rational, chances are they're gonna be like 1/2 or 1/3. Like they're gonna be rational fractions that you can figure out. But my advice is typically I just ignore the decimal ones because they don't want those, and I just find the 0 that is on the whole mark. So I would go 1, 2, 3, 4, 5, 6, 7, or you can actually find it and verify by going in menu, analyze, and capture that one. Uh-oh, what did I do? And I get 7. I typically just ignore the decimal ones, to be honest. But knowing that they're rational, you could find these that way as well. Okay, so I get 1 0 is 7. That's my one, has at least one rational 0. We're gonna find the other 2 with synthetic division. So we use the calculator to get our actual one instead of doing P over Q, P over Q, P over Q. We know this is a 0. Now we're gonna divide. What I think of this as a cubic, I need to knock this down to a quadratic, and then I can solve it to get the other 2. So add 7 and 1 and 7. And I know I did it right. If these are zeros, your remainder has to be 0. So if you get something other than 0 for your remainder, it's kind of a good checkpoint, like, oh, I must have done this right. If you get something else, then you know, oh, I gotta fix something. Okay, so now, cubic, we divided it down. Now it's a quadratic. Put our x's back in. Plus, I've had so many people sleeping today, and they're always in this side of the room. I wonder if I got something over there. Something's over there bugging people today.
At least there's in a car.
Oh, right? We haven't heard the car horn lately. I know. Wow, that's true. It's a good, yeah, you're right. We haven't heard that. Okay, so because they're rational, that tells me, maybe they figured out their part. The rational zeros, that tells me it should factor. Or it does factor. If they're not rational, then they can't factor. So I know 1 and -1. I know that. Negative positive 3. So I'm going to go 3x here, positive 3, negative 2, yeah? Again, you could get those on your calculator, 1/3 and 1/2, but when it's rational, you'll get your nice pretty whole number, and then it should factor. I would set each piece equal to 0, and I get get x equals negative 1/2, x equals 1/3. Okay? So yeah, rational zeros, you could just use your the graph, actually. But with all of these, the process is going to be this, where you find one nice rational zero, divide to find the other two. So they're the same. So then we're going to work on topic 13. What changes is you find out your zeros are irrational.
Oh, Lord.
So it's the same thing, guys, except now they don't factor. Got a few tables processing. I'm going to give them a minute while they're thinking through that. Let me get attendance real fast.
Just keep going. Which way?
Okay, how are we coming? All right, I got my attendance while you guys are processing. Okay.
So where do I write that?
All right, so let's try the next. We're going to skip the next one because we don't need two of those because you're going to see it again with topic 13 and 16. Topic 13, same. The difference is now we've got a quartic, so to the 4th power, and we know we're getting irrational zeros, so like square root of 5. Like we're not going to have nice pretty like 1/2 or 1/3. So the process is still the same. We're going to graph to find its rational zero, not the rational number theorem, rational zero theorem.
Yeah, what about that?
Oops. Okay, 2. So we're going to put it in.
Yeah.
All of a sudden my brain is slowing down. Am I reading my handwriting right? Is this plus 18? Okay, see, I'm going off of this really messy. Okay.
Yeah.
Okay. So we get all crazy, we've got lots of lines. What we're concerned with are the zeros. This is the title tells me ignore the decimals because they're irrational. So we're going to look at the ones that are right on the tick mark. Again, to verify, it looks like -2 and 5. But just to be sure, we don't count goofy or get off one, especially with your small little screens. Menu, analyze graph, and 0. It is +5. Menu, analyze graph, 0. Uh-oh. Let go. -2. So when we have a quartic, power of 4, we need to find 2 rational zeros because we have to divide twice. We have to knock it down to a quadratic. I love this stuff in algebra too. Maybe you haven't seen it for a little while. Do you have it? You have it? You guys just know this stuff? Alright. So we got -2, 5. I know some of you just need to kind of listen next time. -2, 5. Now to find our remaining 2 zeros that are going to be irrational, we're going to do some synthetic division again. It doesn't matter which one you do first. Okay? First period I did -2 first, second period said do 5 first. I did it both ways and we got the same answer. So we'll do 5 first. Again, it doesn't matter though. If you already started this and people are doing -2, you're going to end up in the same place. Okay, so I go 7. And we're going to multiply. Yep, we're going to go through. This should again be 0 if we're doing it right. I have a checkpoint. So 35. And this is 13. I forgot, what is this? 15. 75, thank you. And
65.
oh, 65. I was like, okay, something's not right. This isn't right. Okay, thank you. Oh, there it is. I'm like, I know this for Tom. Okay, so we get our synthetic division. When we're dividing these, it knocks it down a power each time. So this was x to the 4th. This is now, our answer is x to the 3rd. We need to knock it down one more time to get to x squared. So now we're going to divide, we already used the 5, we're going to use the -2, and we just keep going. We just use those coefficients and divide again. And then we're down to a quadratic, then we get to see that quadratic formula again. Whee, right? 7, negative 14 is a little faster. I can math a little better with this one. Alright. So when you have a quartic, you've got to find 2 rational zeros on your calculator, and then do 2 divisions. And the order doesn't matter, which one you do first. Now I put my x's back in. This was 4th power, 4th degree. We divided it down to a 3rd degree. Now we're going to be down to 2nd degree, which is what we're after. Because we know these are irrational, they will not factor. So this is where we can't get away from this, guys. We're going to be using this quadratic formula again. It just keeps coming back, this quadratic formula. So we'll put everything in. Negative b is just negative 1, plus or minus the square root b squared is 1, minus 4ac, all over 2 times 7, 14. This quadratic formula is a big deal. Okay, let's see. We get 1 plus or minus the square root of 29 over 14. So there's our other 2 zeros. Kind of gross, but 1 plus the square root of 29 over 14, 1 minus the square root of 29 over 14. And those are our 2 irrational zeros. So we have the 2 rational we found on the calculator. These 2 are on the calculator, but they're wacky decimals that are irrational, and they don't want the decimals. So we gotta get the exact. Okay, how are we doing? Yay, nay? Okay, nay? Like we're not getting it nay, or just this is painful to do nay? This is painful. Okay.
Make it stop.
Make it stop. I will shortly. Okay, we're gonna skip to 16 now. This is where we skip to 16 because it's the same, except we get complex solutions, which means imaginaries.
No.
Whee! Okay, here we go. Which is why I'm skipping through. I'm not going to do 2 of each of these because it's super repetitive. Although I could have done where I do 1, you do 1, I do 1. I'm already going. We're already this far. We're going to keep going. Okay, so this function has at least 1 rational zero again because it's saying, I forgot. I want to do the last function. It's saying that we're going to have complex solutions, not irrational. So these will not even show up on a graph, at least for this last one. Okay, I wanted to do the last one, sorry. So skip the first one this time, and we're doing the very last one in the packet. So, first move is we're going to graph it again. So I'm going to put this in, plus 7x squared. Same process, we're going to use this to find the rational zero, and synthetic division and quadratic formula to find the imaginary zero. All right, so what are we noticing about this rational zero? Gross, it's a decimal. Yeah, that's going to happen sometimes. So it ends up not being too bad. Like when I first saw it, I was like, seriously? But they were nice in that it divides nice. So I get, let's see, 0. So this is rational. What fraction am I dealing with? Negative 1/3, yeah. So unfortunately our nice rational zero in this case is a fraction. And that's the only one we have. Complex zeros will not show up on the graph. It's not like the irrational and rational. So we got our 1 real zero, and it happens to be a fraction. It ends up not being terrible. So we just kind of have to keep going. I would bring the 3 down. So 3 times negative 1/3,
1.
negative 1. So you see what I mean? It's turning down, okay. You're not going to get fractions here. So just trust the process. Negative 1/3 times 6, negative 2. Plus, so we get 6 again, times negative 1/3, negative 2, and there's that 0 we need. So because we know it's complex, we know it's not going to factor. So we know we need to use the quadratic formula. When it's irrational or complex, they're not going to factor. So here's our friend, the quadratic formula again. Negative 6 plus or minus the square root. B squared minus 4AC. Whew. All over 2A. 2 times 3, 6. So what's going to be under our square root this time? If it's complex. Negative, yeah. So that's the only difference, is now our square root's going to have a negative underneath it. So this becomes actually negative 36. So when I go to simplify this, 6I over 6, all of this divides by 6. So we get 1 plus or minus I. Those are my two irrational roots.
Wouldn't it be negative 1?
Oh gosh darn it, I do that all the time, thank you. Oh, I can't tell you how many times I've gotten stuff wrong in Alice since I dropped that negative. Alright. What are we thinking? Okay. Same, and all three of those are the same. Like, so that's why I did 12, 13, 16 together. Finding rational, irrational, complex. One of each. 14, 15. And then we'll call it a day.
Brain break 1.
I know. The brain break thing kind of has fallen by the wayside because I'm so like honed in on getting you guys a blended day, but a brain break we could do a fast one. Like jumping jacks or something. A stand and stretch, we could do a little stretch. I do have a little fun story I was telling you about the volleyball team, or T. Last period I did a little story time.
Yes.
12, 14, that's right. I gotta explore it spot. 13, I skipped that one, 14. Oh, 16, oh, I went back to the wrong direction, that's right. I reordered that. Okay. So my little side of this story can be like the T girls played, it's playoff time, you know, just like football. And they played Lennox, and it was a really, really good game. Like, they played super, super good. And our whole, I swear, like, the whole football team, I think, went to Lennox to cheer them on, and they were like, wow, rowing crowd. It was amazing. And they won. So at the end, have you guys seen the Remember This Titans movie?
Yes.
With Denzel Washington? Okay. I was like, you won't get this. But they, at the end, because they won, they sang that little chant, like, yes, thank you. I'm like, I know someone will know. Like, how does it start? Like, we are the Titans, the mighty, mighty Titans. And they did that whole thing, like, for the volleyball girls. Wasn't that cool? So a football guy, that's what you need to do. Go cheer on the volleyball girls, and then you can sing afterwards. Or chant afterwards.
Hey, you get it.
Anyway, all right. I just thought that was a fun story. It kind of came up in context last period, but I thought I'd share it this period since I have some volleyball people. See ya. All right. So, topic 14. Are you ready? This first one, we're like, we can do this, right? So this one is just distribute. We get x squared plus 5ix. Distribute minus 5ix. Uh-oh. Minus 25i squared. So we're jumping back to 14 now. We're going to finish this out with 14 and 15 today. And then we'll call it a day. This is gross looking, but
I wasn't here for it.
where this is saying simplify your answer as much as possible, what they're getting at there is you won't ever leave an I squared. You're going to change that to -1. You won't have any i's in your answer for these. So this is what happens. These are complex conjugates, meaning 1 plus, 1 minus. So these reduce out. So we're left with just x squared minus 25i squared. And we have to recall, what does I squared equal? -1. So this just becomes x squared minus 25, so plus. So this is x squared plus 25. Okay, so that one's just sort of an introduction level. The next one you can see is a little bit more involved, the next couple. So I'm going to do 1 and then have you guys do 1. To kind of get a practice. And I can make a loop and see how we're doing. How's this now?
You distribute inside first.
That's what I'm going to do, yes. So I used to teach this in Algebra 2, but we really don't anymore. Or I haven't. So I did it the big long way, and it was crazy. And I ended up in the right spot, but I'm like, I forgot there is a shorter way. So, when you have this, what I would do first is distribute the negative, and just kind of, we're gonna rearrange a little bit. Okay, there's that. And then this bracket, I'll distribute the negative. And this should happen every time, plus minus. Plus I minus I, they always come in pairs, plus or minus. Okay, so what I do then is I'm gonna go parentheses here. And because I know it's a conjugate, plus I minus I, this is gonna happen every time. Where these middle values cancel out every time. So when I go to do this one, I am only going to do the first terms and the last terms. So that'll look like this, x minus 6, times x minus 6. The negative I, x minus 6, plus positive I, x minus 6 are gonna cancel. So I'm not gonna even mess with those. And then I'm gonna take I times I, which is plus 1. Now it's not too crazy. Like if we just-
I'm doing.
I know, yeah, there's a big long way to do it. This way regroups it a little bit, so, and takes our knowledge of like a complex conjugate, those middle terms cancel, so then I can just do this.
Oh.
And I end up with this. So that's what it's wanting you to do there, is multiply that out. Alright, I'm gonna give you guys a chance to try that last one. So the last one, give that a go, make sure you got it, but I can answer any questions if people are having any issues with that. So try that last one.
And that's it for today?
No, we got, this is 14, we got 15. How's it going back here? Oh, I know, the knowledge checks are kind of killing me. Alright.
What am I doing?
Okay.
How long I.
So, I know some of us are sort of DUED done for the day, it sounds like.
What are we on now?
Alright, I'm just gonna work this out real fast.
It is Friday.
So I distribute the negative, regroup, we end up with this.
I might say first period,
Yeah, that's what we got?
Sounds good, right?
Sure, okay. Alright, last topic for the week, because then tomorrow will be topic work time, test time, retake time, practice test, whatever you're still working on. So, find a polynomial f of x of degree 4 with real coefficients and the following zeros. Okay, so, here's a couple things we have to talk about. First, we have to understand this multiplicity of 2. What is that telling me?
Squared.
Squared, x plus 3 squared, right? So my factor would be x plus 3 squared for that multiplicity of 2. We also have to know that if I have a positive I, they always come in pairs, always, always. So if I have a positive I automatically have a negative I. They're always plus or minus, always. So when I go to write those factors, I have x minus I, x plus I. After that, it's just a lot of multiplication.
No.
And distributing. So once we get just, okay, this is a double root, it's a multiplicity of 2, and we remember we need to add in that negative I. After that, it's a bunch of distributing and multiplying. When I do these, just personal preference, well, actually I think it would make life really crazy if you didn't do it this way. I do the imaginaries together, the reals together. By doing the imaginaries together, then that canceling out all happens. So, this first one, I'd have 2x squared 6x plus 9. The second one, if I distribute x squared, I get ix minus ix. That happens all the time, or every time with conjugates. Minus I squared. So when I distribute this, x times x squared, I times I, negative I squared. That ix minus ix happens every time because they're conjugates. So I don't necessarily need to write those. Alright, so this would be a bunch of multiplication now. X squared, this is minus a negative 1, right? So plus 1. And now we're distributing. Jake, you see it? And then you, when I like distribute these, I might do it differently than you guys, but you can multiply in any order. 6x equals 9x squared plus 9. And then now we can combine like terms. So my x squareds can go together. I'll put it in standard form. I'd have x to the 4th plus 6x cubed plus 10x squared. Where's my x? Do I have an x? Plus 6x plus 9. Oh no, not plus 9.
Plus 9.
Oh yeah, yeah. I'm thinking of the last one. I'm thinking of the last one. There's a plus 1 at the end. Whew. Okay.
Plus 9.
Plus 9, yeah. Alright, so looking at one more, guys, because there is a little, this is a binomial. 3 minus I know. 3 minus I, so we automatically have a 3 plus I that we know happens. They always come in conjugates or pairs. So we would have x minus 1, x minus, this is kind of what we just did a second ago with that multiplying, x minus 3 minus I, x minus 3 plus I.
This is making my toes hurt.
Right? This is kind of crazy.
It's making my toes hurt.
When we're writing in factored form, it's always x minus, oops, this should be plus, is that what you're?
Yeah.
Yep, okay, thank you. You're always doing x minus, x minus, x minus. So it flips your sign. So that's why I know this is x minus this, x minus, like we did before. I'm gonna distribute and rearrange here, so I get x minus 3 plus I get x minus 3 minus I. And we'll kind of group these two like that. And now it's all just multiplied out again. Ugh. It's a lot of multiplication business. So, let's see. Once you get this set up, it's all distributive property after that. So now I would have x minus 3, x minus 3. This is the plus 1 I was thinking of. Oh wait, so better be careful. That plus 1's on the outside. It's got to be added last. And when I distribute these, I'm going to kind of group like terms as I go. So I have x to the 3rd minus 6x squared plus 9x, then the 1, x squared minus 6x plus 9 plus 1. That way they're grouped as you go. So now I have x to the 3rd minus 5x squared. I gotta finish it out. I know I'm out of time. Woo! Alright. So tomorrow, blended day. If you're missing your test 2 yet, you have to be here. If you're under an 80% in the class,